Paul is the co-founder of MesoMat, and he will talk about stretchable piezo-resistive yarns for strain sensing in high deformation systems. Slides look good. The stage is yours, Paul.
Good. Yeah, thank you. My name is Paul Fowler. I'm the co-founder and CEO of MesoMat. So the foundation of MesoMat is a new type of sensor which works in many systems where traditional sensors fail. And our sensors are these thin, stretchable, conductive yarns which measure strain or deformation. And in just a moment, I'll actually show you a demo of the technology so you can see how this works. And today I'll be discussing a lot about the sensors and how they operate, but I'd also like to mention that as a company, we combine this fundamental sensing innovation with electronics and software to provide a platform that can be used to optimize efficiency, performance, and manufacturing in some of the world's most widely used industrial materials, things like tires, construction materials, infrastructure components, and so on. So the operating principle behind our technology is very straightforward. We produce yarns that are piezo-resistive, meaning as they are stretched or compressed, there is a change in their electrical conductivity. Of course, this provides a very simple way to measure stretch or strain. And really, if think about one thing that makes our technology and our sensors unique, it's the ability to measure large strains. As you know, most solid state strain gauges are optimized for very small deformations. Our sensors can measure strains larger than 20%. So the best way to understand how this works is to see it. So I'm going to jump out of the slides here and actually give you a brief demo of our technology, and then we'll dive back into things. Okay, so now you should be looking at me. Here is a spool of some of this yarn. So this yarn is made up of many individual filaments. If you can see here at the end, you may be able to see that the end of this yarn, let's see, is sort of frayed there. So you can see there's a number of individual filaments that are wound together to make this yarn. It's very, very stretchy. It's made of a thermoplastic and nanoparticles. And we can stretch this by up to 50%. As we pull on it, the resistance changes, so we have a strain sensor. What we typically do with this yarn, sometimes we use it as is, we often incorporate it into things like a sticker or a tape, which you can easily just slap onto the surface of a material, and then you have this kind of instant smart material. So I'm going to show you that in action here. What I've done is taken one of the stickers that I just showed you, and I've stuck it onto a plastic slab. There's nothing inherently special about this plastic slab. It's just a piece of material. And if we once again share my screen, you are now seeing the data from this is streaming to the cloud. And what you will see is if you look at me in the tiny left corner, if I bend this, you can see the corresponding change in deformation. So as I bend this plastic slab back and forth, you can see in real time that we are measuring the deformation in this material. So this is how this works at a very basic level. And I will now go back into the slides here and explain a bit more details about things. Good, so we're back here. So you've seen the technology in action. Now I'll briefly explain a little bit about how this material is produced, some of the key technical specifications, and how we're using it as a sensor. So in the top image on the slide here, you can see an optical microscopy image of one of the yarns, which I just showed you. As mentioned, this is composed of many individual thermoplastic fibers. Each of these fibers are on the order of 10 microns in diameter. And as you can see, they're twisted together to form a structure that is much like a rope. In the bottom left corner of this slide is an optical microscopy image of one of the individual fibers which comprises this rope. And the main thing that you should be looking at here is that each of these filaments in the rope is coated with high aspect ratio conductive nanoparticles. And in the bottom right